Some say dirt, some say soil. But whatever you call it, it's as important as the plant material and the landscape design you create. And here to talk to us about soil, or dirt, is Dr. Gene Stutz, urban horticulturalist at Arizona State University. How exactly do you define soil?
Well, soil is defined different ways depending on who you're talking about. The definition you'd get from an engineer would be quite different from a horticulturalist, but horticulturists usually define soil as the weathered portion of the Earth's crust that plant roots grow in.
And what do you mean by the weathered portion of the Earth's crust?
Well, this is the rocks are weathered by wind and rain into small particles, and that's one of the components of soil. But it's definitely not dirt. Dirt is when you get soil under your fingers when you're gardening or on your clothes, and that's what we would call dirt. Today we're going to be just talking about soil.
Okay, so in addition to the weathered rock particles, what else are we going to find in soil?
Well, I think first we want to talk about how soil supports plant growth. And there's basically two ways in which soil supports plant growth. First of all is as a mode of support for the roots. There has to be something that holds the plant stationary, and that is the roots in soil. And the second way in which soil supports plants' growth is by providing the water and nutrients that are required for growth. Anytime that you substitute something for soil, you have to provide all three of these: support, water, and nutrients.
So soil acts as a reservoir for nutrients and other ingredients.
Yeah, that's correct.
Okay. So what exactly is it made up of? What are the components of soil?
Well, there are actually 5 components of soil. The first is, I'm going to show right here, and that is actually the particles that we talked about before that are weathered from rock. And these provide the bulk of what soil is made up of. The second component is the organisms that live in the soil. Some people don't realize it, but soil is actually a living thing. We think of it as an inert substance, but it's actually living. And when you think about it, you're familiar with some of these organisms, like earthworms and insects that live in the soil, moles. But there's also some very important microorganisms that live in the soil. And I brought an example of one today, and that is fungi, which are down here growing in these flasks. And fungi are a very important microorganism in the soil. As a matter of fact, they are the most prevalent microorganism that live in the soil and very important in soil function. The third component is organic matter, and I brought some organic matter here. Organic matter normally consists of the dead and decomposing organisms that live in the soil, such as the fungi, bacteria, earthworms, and also consists of dead and decomposing leaves, bark, and roots of plants. So it is the third component. And then the fourth component is water, and I have a little bit of water here to mix up with to make our soil. That's one of the components, the fourth component. And the fifth component is atmosphere or air. And the water and the atmosphere components are in the spaces between the mineral particles, which are sometimes called pores. And they occupy the same space. So when there's a lot of water in the soil, there's very little air. And when there's very little water in the soil, there's a lot of air in that space. And it's good to have a combination of the two because in the atmosphere, the oxygen in the atmosphere is required for root growth. So if you overwater your plants, have your soil constantly saturated by water, this isn't very good for plant growth because you're lacking the oxygen that's required for plant growth.
I was raised sort of believing that the loamy soils were the best soils to use. Is that true?
Okay, loam is a term that refers to soil texture. And texture is defined by the types of mineral particles and the size of mineral particles in the soil. The largest mineral particles in the soil are defined as sand. And then as we get a little bit smaller, we talk about silt particles, and then the finest or the smallest particles are clay particles in soil. And loam soil is probably the best type of soil because it's approximately an equal mix between sand, clay, and silt, the three components.
How can I determine what my soil texture is?
Well, there's a variety of ways of determining soil texture, but one of the easy ways is sometimes called a field test, and by that I mean I'm going to feel the soil. What you would do in this case is you take a little pinch of soil like this, and you would add a little bit of water to it. And you would just rub it back and forth in between your fingers.
I feel that.
Now this is a pretty sandy soil, and you can feel that it's gritty.
Yes.
Okay.
Yes.
The characteristic of sandy soil is that it's gritty. Soil with a lot of silt in it would be soapy or slippery in its feeling. And you almost can feel a little bit of silt in this soil. It's a little bit slippery if you feel it down. There's not very much clay in the soil. Clay comes out feeling very sticky, and if you move your fingers back and forth like this, it would almost stick to your fingers, and you'd have this kind of sticky material coming back and forth in between your fingers if you have a lot of clay in your soil. There's other ways of determining textures. There's actually soil survey maps where you can actually look up your area on the map, and they're available in the public library, and you can find out what the texture in your area is too.
Which would be very important in terms of planning your landscape, to know what the texture of the soil is before you start.
Well, knowing the texture is important for several different reasons. One important reason is to determine how often you should be watering. Water does different things in different types of soils. For example, in a clay soil, we have the tiny clay particles, and in between those tiny clay particles, we have tiny pore spaces. When it rains or when you irrigate, the water that's going to enter into the soil enters into a clay soil very slowly because there's not very much pore space for it to go into. And as it moves through those pores, it has to move in a very circuitous route that is moving between those tiny little pores. So what happens is it takes a longer time for water to enter into clay soil, but once it gets in there, it takes a longer time for it to move out of the clay soil. So it's in the soil for a longer period of time. Now, in contrast, if you have a sandy soil, the particles, in contrast, are big. If you would want to look at them on a scale that we would understand, they'd almost look like boulders compared to little pieces of dust. And because the particles are big, the spaces between them are also big. So what happens when you irrigate or you water is that the water goes into the soil very rapidly. You don't have any problems with flooding when you have a sandy soil usually, unless it rains very hard, very fast. But it moves through the soil very quickly because there isn't that much of a route for it to travel through those big pores. So in a sandy soil, the water moves through more rapidly, and it's unavailable for plant roots to take up. So you would need to water a sandy soil much more often than you would need to water a clay soil. And the loam soil is kind of in the middle. So water enters into a loam soil very slowly, slower than it would into a sandy soil, but it also is retained longer than it would be into a sandy soil. So it's actually, for water holding properties, it's better than a sandy soil too.
If soil, as you mentioned earlier, acts as a reservoir for nutrients, what are some of the nutrients that are really important for plants to have?
Okay, there are 13 nutrients or minerals in the soil that are required for plant growth. And all of these are required, but in different concentrations. And we can divide the nutrients into two groups depending on how much is needed for plant growth. The first group would be known as the macronutrients, and these are required in high amounts by plants. And there's 6 of them, and probably the most important ones as far as having to add them to the soil occasionally are nitrogen, phosphorus, and potassium.
That's why when you see on the labels the NPK, nitrogen, phosphorus, and potassium, that's what you're looking at.
That's what you're looking at, how much nitrogen, phosphorus, and potassium are in them. So, for example, we have a fertilizer bag here that has the nitrogen, phosphorus, and potassium amounts in it. And this is a superphosphate fertilizer, which means it's just made up of phosphorus. So it has a lot of phosphorus in it, no nitrogen, no potassium. So if you have all 3 of these elements in the fertilizer, it's called a complete fertilizer. But if one is lacking, it's not a complete fertilizer. So those are the macronutrients. Now the micronutrients are the nutrients that are, or the minerals that are required in less amounts, but if they still are required for plant growth. And there's 7 of these, and probably the most important ones as far as being required in the highest amounts are iron, zinc, and manganese. The nutrient deficiencies that we very commonly see here, the most common one is nitrogen. And actually, nitrogen deficiencies are probably the most common deficiencies worldwide, so we're no different from any place else. And plants, when they are nutrient deficient, have certain symptoms that they see. One of the things that happens when a plant is nitrogen deficient is that it grows much, much slower. And for instance, your lawn requires a lot of nitrogen for growth. And if you don't fertilize it, what will happen is it will start growing slower and slower and slower, and sometime you'll have to stop mowing it, and then you'll really know that it needs to have some of that nitrogen fertilizer on it. But other plants show their deficiencies in other ways, and I have some some plants here with nitrogen deficiencies, and this is some orange leaves, a branch off an orange tree. And one of the symptoms is that just a general green color to the leaves, so they're not as green as they normally should be. And in addition, we get yellowing of the older, lower leaves. So here is the bud, and here are the younger leaves, and here are the older leaves on the bottom of the branch. And you can see that they are much yellower than the new leaves, and this would be very typical of nitrogen. It's also falling off right now. Again, here's another example. This is a lettuce plant, a little lettuce transplant with a nitrogen deficiency. It also wasn't watered, and it's showing a little bit of water stress here. But again, the lower leaves, and in the lettuce is kind of hard to see because of the growth habit, because it's a little rosette, but the lower leaves are the yellower color, whereas the newer leaves are green. So that's the difference between the two. And one of the reasons why this is the case is because nitrogen is very mobile in the plant, and it can move around very rapidly, and it can move from the older leaves where it's not being used to the newer leaves where the plant is actively growing. So this is kind of a survival mechanism. Nitrogen is required for growth, so what the plant does is it kind of sacrifices the older growth to provide nitrogen for the new growth. Plants require a lot of nitrogen to make proteins, and because there's a lot of proteins in plants, they need a lot of that nitrogen. The most common source of nitrogen for plant uptake is in the decay of organic matter in the soil. What happens is the organic matter is broken down in the soil by microorganisms, by earthworms that eat organic matter and process it through their bodies. And as it's broken down, the nitrogen in the proteins which are being broken down is made available for plant use and plant uptake. Now here in Arizona, we don't have very much organic matter naturally in their soil. This major source of organic matter is leaves and roots of plants. And here in the desert, there's not that much plant cover compared to a forest or a grassland where you would have a lot more biomass or leaves being produced. So our soils, our mineral soils, they're very naturally low in organic matter, so that organic matter is not there for plant for breakdown and then for nitrogen to be released to be taken up by the plant. Another deficiency we see quite commonly is iron deficiency. And I have also 2 examples of this. One is a myrtle. And nitrogen deficiencies, the symptoms are exactly opposite of, iron deficiencies are exactly opposite of nitrogen deficiency. And that is, you see the symptom first on the younger leaves. And you can see here these older leaves are green still, and the younger leaves that are starting to come out are starting to get yellow. And that is very typical of an iron deficiency. And this is because iron is relatively immobile in plants. It stays in the older leaves and is not translocated or doesn't move up to the new growth. Oh. Another type of symptom you very typically see for iron deficiencies is what is known as intraveinal chlorosis, or sometimes it's called iron chlorosis. And in this case, what we have is the veins remaining green, and the area between the veins getting green. It can almost look spidery, like a little spider web in there, and that's what it looks like. And that's called iron chlorosis sometimes.
Why are iron and zinc deficiencies so common here?
Well, it's a different reason than why nitrogen deficiencies are common. It has to do with the pH of the soil. pH is a term that refers to the concentration of hydrogen ions in a material, and pH can range from values can range from 0 to 14. A neutral pH is considered a value of 7, and a neutral soil would have a pH of 7. Acid soils have a pH of less than 7, so they would be pHs of normally 4 or 5 or 6. And alkaline soils have a pH of greater than 7, so they would have pHs of 8, 9, or 10. Now, our soils here in Arizona are alkaline, and their pHs are usually greater in the valley than 7. And the plants actually have a preference for living at a slightly acidic soil with a pH between 6 and 6.5. There's some plants that are called acid-loving plants, the rhododendrons, azaleas, camellias, that grow best, gardenias, that grow best at very at acid pHs, and a lot of times they don't grow very well here because our pHs are too high or alkaline. There are other plants that grow best at alkaline pHs. For instance, alfalfa is one. This might be one of the reasons why we see so many alfalfa fields around here, because that is an optimum pH for alfalfa, is about 7.58. But in general, what happens as we get into the alkaline pH range is that iron and zinc become unavailable for plant use. And what this means is that the iron and zinc particles become insoluble in the soil, and all nutrients are taken up in solution. They're taken up with water in the plant. And this is one of the reasons why when we have drought, we see nutrient deficiencies very often, because there's not that much water being taken up. But if the iron and zinc is insoluble, then it can't be taken up by the plant. And as the pH gets more and more alkaline, then the iron and zinc get more and more insoluble.
Well, how do we change the pH? If we've got an inappropriate, if we're in the alkaline, we want to bring it down, how can we change the pH?
Well, there's different ways of changing pH, and you can either increase or decrease the pH. And if you, in this case, we would most likely, if we have an iron deficiency, there's different ways of trying to make the plant better from that iron deficiency. One way would be to add chelated iron to the soil. And what happens with chelated iron is an iron particle that is surrounded by a chelate. And because of that chelation, it does not become insoluble in the soil. If you just added iron to the soil, it would become insoluble just like the iron that's in the soil. The problem isn't that there's not enough iron in the soil. So you could add an iron chelate, and that chelate would protect the iron molecule and let it be taken up by the plant. Another thing that you could do would be to decrease the pH. And there's several ways of doing this. One is you could add something like soil sulfur or gypsum, which are both very common amendments to the soil. But anything that's acidic would do. So, for instance, you could add your coffee grinds that you drink in the morning. You think about coffee as very acidic. The other thing that you don't want to do is you don't want to add lime to your soil. A lot of people come to Arizona from areas where liming is very common. I know I grew up in an area where every year my dad would have to lime his lawn to make it grow well. And that, in New Jersey, where I grew up, that's a good idea because the soil is acid. One of the things that liming does is it increases the pH of the soil. And that's exactly what we don't want to do here.
So I'm assuming that even the way we fertilize and feed our plants is going to be a lot different in this area. How do you fertilize here?
Well, actually, it's not that much different. We still would add supplements to the soil, which are called fertilizers. Sometimes these are called plant food. And that's really an inaccurate term to call them plant food, because plants manufacture their own food using photosynthesis. So they're not food for the plants. They're more comparable to the minerals that we take in our vitamin and mineral tablet every morning if we want to be healthy and get the appropriate amount of minerals and vitamins. So they are actually nutrients we add to the soil in different forms for plant growth. And there's very many different kinds of fertilizers. One basic distinction between types of fertilizers are organic and inorganic fertilizers. And organic fertilizers have as their source an organic product. It could be a byproduct of animals like manures, chicken manure or steer manure are all organic types of sources of nitrogen. It could be bone meal, where we grinding up their fish meal, where we're grinding up bones, which are very high in phosphorus. So these would be organic types of fertilizers, and people who are organic gardeners would only use those kinds of fertilizers. The other type of fertilizers are inorganic fertilizers, and these are normally either mined or they are manufactured. For instance, ammonium nitrate would be a very common inorganic fertilizer, and it is actually produced in a chemical reaction in a fertilizer plant and manufactured. So those would be inorganic fertilizers.
What should we look for when we go to buy fertilizers? First, we have to know what our soil is, to know what it needs.
Yeah, well, usually you want to, in most plants, if you're going to fertilize them, they are going to need a source of nitrogen. So you want to have a fertilizer that has a source of nitrogen. Now, one of the things about organic and inorganic fertilizers that also distinguishes them is that in the organic fertilizer, the nitrogen is released very slowly in the soil because the organic material has to be decomposed by the soil microorganisms for it to be available. So you would have to fertilize less often by adding an organic fertilizer. Whereas with the inorganic fertilizers, they are very quickly either leached through the soil solution or taken up by the plant or used by microorganisms for their growth. So you have to fertilize much more often with the inorganic fertilizers. Unless you use something called a slow-release inorganic fertilizer. And I have an example right here. It is actually a fertilizer, a nitrogen fertilizer. It actually has nitrogen, phosphorus, and potassium in it, and it's coated with a resin. And as you water your plants, that resin breaks down and it very slowly releases the nutrients to the plants. Another type that very commonly is used is a liquid fertilizer. And in this case, you would be adding fertilizer powder to water, and normally it has a little blue or green color to it so you can see what you have in it. And then this is watered into either the soil or into your container. And one of the advantages of this is if you have nutrient deficiency, because it is water soluble, it becomes very rapidly available to your plant. So if you have a nutrient deficiency, this can be very rapidly added to the plant. It can be also applied to the foliage, and sometimes that's called foliar feeding.
Will this, if I feed this to foliage that is showing nutrient deficiency indications, will this change that, or
no,
will that remain damaged?
If the leaves are small, usually it doesn't remain damaged, but it will, the chlorosis or the yellowing will start to go away. Now, one of the things you want to be careful with when you foliar feed or apply any fertilizer is that you mix it up at the right rate. Because, again, we're applying salts. And if you think that twice the amount of fertilizer is going to be good, you're going to be sadly disappointed, because what's going to happen is you're going to burn out your foliage. And this is very commonly done, for instance, in turf in the summer. People say, oh, I haven't fertilized my turf, my lawn for a long time. The bag says I should put 4 pounds per 1,000 square feet on, and I'm going to put 10 on. Well, that's
just because I haven't done it for a while.
Because I haven't done it for a while, and they need that nitrogen. Well, that's the worst thing you can do, because you're going to scorch out your turf, right, and not have anything very good to look at.
I always follow exactly the directions. I figure they are professionals and they figured it out. I don't understand, and I know you're right. People do that. They will. Some's good, more's better. So that would be your advice.
Yeah,
not true.
It's just like with pesticides or nutrients. You want to follow the label directions for the appropriate use of the product.
Are there any other fertilizers we should be aware of? Types of fertilizers we should be aware of?
Well, one of the most common types of fertilizers are granular fertilizers, and these are applied to the soil or incorporated into the soil, and they are incorporated as a granule. They're usually either broadcasted over the surface of the soil and then incorporated in, or they can be applied individually to plants. And this is an example of a granular fertilizer here. It's actually the superphosphate that was in the bag that we looked at earlier, and that would be an example.
Well, that's excellent, and it's wonderful to know the importance of the role of soil in our landscape plan. The soil used for potted plants is a different story altogether. In fact, some of it isn't soil at all. ASU Botany Department horticulturalist Margaret Gibson talks about the difference.
The difference between soil and soilless mixes is that soil is outside and it has pests in it, insects, and also disease, pathogens. And the reason that we use soilless mixes is because they provide a better aeration and better drainage, and they are lighter. Generally, we use bark that's been composted and vermiculite and perlite and sand. And the peat that is used very often is a problem because sometimes it's hard to wet. And a lot of times what we use in the peat is we use a wetting agent like an ivory soap. And we would mix that with the vermiculite and perlite to make a mix that would be lightweight and easy to plant with. And sometimes we use sand when we're doing a succulent plant, such as the jade. And this causes better drainage for succulents. If we're going to be potting up dracaenas, such as this Warnicki, we want to be careful not to use perlite in the mix because it does cause fluoride problems, such as this tipping and discoloration in the leaves. Basically, you want to use a mixture that drains well, so you want to make sure that you have it evenly mixed. What I generally use here in the greenhouse is a mixture of 2 parts what I call super soil, and it's basically bark that's been composted, and I use 1 part vermiculite and 1 part perlite. Almost all the plants in the greenhouse could use the standard mix with the exception of the succulents and the dracaenas.
Unless you have a lot of plants to pot, Margaret says, don't try to mix the ingredients yourself. It's too expensive. Just use what you've learned today to choose a pre-mixed potting soil. For Southwest Home Horticulture, I'm Diane Purd. Goodbye for now.